This is John Black, Super Chemist, JBSC. Well, this is part 2 of how to get aldehydes from bleach or hypochlorous acid. Okay, I wanted to go over a couple mistakes I did in the first video. One was PCC is a mild oxidizer, and I put it in the list with potassium permanganate and potassium dichromate, and those are strong oxidizers. It shouldn't have been. It should have been in the list with the chromal chloride and with KCC. The thing about the PCC and the KCC and the chromal chloride is you need either dichromate or chromate. Otherwise, you're going to spend a long time trying to make it because they have such a high molar mass. You have to make so much. Oh, and also on the pH, I said, and this is true, it says it in Wikipedia, that non-iodized HOCl, which is the hypochlorous acid, which is the oxidizer, is highest at pH of 4, okay? Now I see a teacher doing this experiment, right? And a teacher says that he used an acetic acid buffer, so I was right, it is used, this is kind of a buffering thing, with a 5.5 pKa, okay? So, before I knew it was between 2 and 6, and I was guessing 4. Now I know that it's between 4 and 5.5 pH, and that, it's somewhere between there. I would probably do a 5. You know what I mean? A 5 pKa or a 5 pH. Also, anytime I have something up on the board and I don't talk about it or I don't bring anything up about it, that means it's either wrong or it's for something else that's, above the board or below the board that you can't see. And I just did the camera wrong. I shouldn't have had it on the board at all. One of those things in the part 1 was it said add some type of carbonate to suck up the HCl that you make during this reaction. Disregard that. If you notice, I didn't talk about it, so that means that it was for something. It was actually for something else that was on the board above it. So just disregard that. So I just wanted to mention those couple facts. All right, so I'm going to start continuing what I was talking about in the first video. I just wanted to go over those mistakes and get them out of the way. So let's go back to what we were talking about in the last video. Okay? You're going to have vigorous stirring. You have to have vigorous stirring, okay? And then you put your bleach up in the set funnel and you drip it in. The reason why, okay, that way your pH is set. You want your pH to be set at a pH of 4, right? Because that's where all your hypochlorous acid comes from, and that's your oxidizer. The acetic acid is going to have a lower pH, I believe. But this coming in, right, the bleach coming in has sodium hydroxide in it, etc., and it's going to react with that. It's going to make the pH go higher and less acidic, right? By dripping it in, it's almost like a buffer, I think. You know what I mean? You're going to keep the pH at 4 at all times by doing it that way. And not only that, by dripping in the bleach, you're controlling the temperature, right? Because if you add it in fast, it's going to, you're going to have a lot of heat. It's going to be very exothermic. You won't have enough time for this water to dissipate it. The great thing, this should be a warm water bath. Well, I just learned the exact temperature range. It's between 45 and 50 degrees Celsius. The nice thing about the warm water bath is, if because this is going to produce heat, it will suck up that heat and have enough time to dissipate it to the air. You know what I mean? With no problem, since you're just dripping it in. You're not dumping it in all at once, you know what I mean? And the other thing is that if the reaction isn't warm enough, it's surrounded by this warm water bath, so it will keep it warm. You know what I mean? It won't let it get too cold and it won't let it get too hot. It'll keep it at that warm temperature. But you should keep track of the temperature with your thermometer just to be sure, you know what I mean? And how do you drip it in? How do you know how fast? If you've ever done a titration, you'll know what I'm talking about. You want to drip this in so that, and it's stirring, 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 stirring. You want to drip it in so that it changes like the top layer kind of green. You know what I mean? Maybe the first inch of the top layer green, because that's what bleach is. It's green, and then it disappears, and then it keeps dripping in, and it turns green just for a little bit. You know what I mean? Then it all disappears, kind of, and then it turns green, and it disappears. If you've ever done a titration, at the end of the titration, where you drip some in, and it gets a little pink or purple or whatever color it is, and then it goes away, and you put some more in it, and you're like, oh, okay, that's the end of the reaction. It's titrated, and then it goes away. So you add some more, and it keeps going back and forth. That's the perfect rate you want to drip this at. You want to drip it so that you don't have too much in there. You don't want to oxidize all your stuff to chlorine. You want the pH to be 4. You want the temp to be warm. And that's how you do it, by dripping it in at that rate. Now, I wanted to mention, okay, if you have sodium hydroxide in your bleach, then you will do the haloform reaction instead of what we wanted to do was oxidize it to a ketone or a aldehyde, right? And I'm going to show you why. I already have a video on the haloform reaction, so I'm going to go over the mechanism real quick here and then talk about it. Okay, now I'm using this example, octanol. Well, it's actually a ketone now. But let's say you did this reaction and you had 2 octanol. And it's going to go up to 2 octanone, a ketone. Remember, we're still using bleach. Let's say we have the 2 octanol that we put it in the bleach and it will be oxidized to the ketone 2 octanone, right? Now, if we didn't put any acetic acid in there, there'd be a whole bunch of sodium hydroxide in the bleach, along with chlorine and etc., right? Now, what happens if you have sodium hydroxide in there, okay? If it's a methyl ketone, meaning you have a methyl on one side, okay, it will go through this haloform reaction because you have sodium hydroxide in there. Now, remember, we wanted hypochlorous acid, and the hypochlorous acid would protonate the water group, and then the OCl would come in and do an SN2. Here, because you have the sodium hydroxide, instead of protonation and blah, 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 it wants to rip protons off of stuff. And it chooses the alpha hydrogen on the methyl group. And then you have an enolate, right? And you can draw it either way, and you can think of it either way. Either the double bond has so much electron density, it tries, and this has like a dipole, an induced dipole, or just a spontaneous one. Or you can think of it in this one, the electrons come down either way. Both of these can do it. And then these electrons go to the other chlorine, making chloride. And then you come down here and you can see you added on a chlorine onto the alpha position, or you took the hydrogen off, right? And what happens is the OH just, from the sodium hydroxide, it just keeps doing that, because there's 3 hydrogens on here, so it'll take a second hydrogen off, replace it with a chlorine, and a third one until you get to here. Now, look at this. You got 3 chlorines on here. This would be a perfect thing for an acyl transfer, because if this methyl group with the 3 chlorines come off, it comes off negative. Who cares? You got 3 very, very electronegative atoms on there. That negativity will be shared 3 times. 1/3 here, 1/3 here, and 1/3 here. Those chlorines laugh at that little bit of electron density. They want more. You know what I mean? So this easily comes off with an acyl transfer. So now, since there's no more protons to grab, the OH comes in and does an acyl transfer, and you end up with the OH comes on instead of the free chlorines, and you have a carboxylic acid, and you have chloroform. Now, I was thinking that, the method that was done that I said so far, dripping in the bleach into the acetic acid and the alcohol, I was thinking, well, wow, man, since you're almost like titrating it, you have plenty of time to do the haloform reaction, or at least some of it. But now that I see this teacher doing this, obviously he doesn't care. He made this ketone without having to do the haloform reaction by doing the same way I'm telling you in the video. You know what I mean? And he didn't seem to care. So the hydroxide must react with the acetic acid first before it even tries to do this reaction, at least in most of the molecules. But if you were leery about it or whatever, here's a guess. There's something else you could do. But like I said, he did it, so why can't I? You know what I mean? Or anybody. And my idea is just to drip some acetic acid into bleach until you get a pH of 5, or between 4 and 5.5, right? Then all the sodium hydroxide has been neutralized, right? Because it's a pH of 5, or somewhere around here. So you definitely know it's all gone, and you know that you have a good supply of HOCl, your hypochlorous acid, which is the oxidizer. Then just drip in that mixture into the alcohol. You know that it's the pH before you start dripping it in, right? Just do the reaction at, still 45 to 50 degrees Celsius. Put a warm bath on it, make sure, just do it the same exact way. But, like I said, this was a teacher that did it this way with the 2-octanol, and it worked good for him. So now, how do we clean up stuff? You know what I mean? 'Cause you're probably going to have some bleach still in the solution. Like when you're done with this, you're going to have some green tin in there, some chlorine. How do you get rid of the chlorine? Well, let's go over that next. Alright, when you're done dripping it in, you might want to stir it for 10 minutes, 15 minutes or something, just to make sure it's whatever done. You're most likely going to have some chlorine still in the mixture. You don't want that. Use some Ki starch paper strips to test. Dip your stir rod inside the flask and get a little bit of liquid on it and dab it onto your starch paper. Now, if it has chlorine in there, the chlorine will take over and become potassium chloride, and the iodine will come out of solution and turn the paper purple, right? And there's chlorine still in there. There's still stuff. So you just use some 10% aqueous sodium thiosulfate. I mean, it could be 20%, it could be 30%, whatever. You use some of that to neutralize that chlorine and get it. And then you do your starch paper again, give it a test. If it turns purple, add some more thiosulfate. If it's clear, then you're good. You don't have to add any more. If you don't have any Ki starch papers, just go by the color of the solution. The solution should be milky white. No green color, no yellow tint, no color in it whatsoever. If it does have color, then you need to add more sodium thiosulfate. If you don't have the Ki starch papers, you can make that if you have any kind of iodine salt. Just put it in some water solution and get a piece of paper, cut it into a strip, and dip it into the iodine, the sodium iodine solution. Make it, put a lot in it so it's almost as much as you can get in there, or saturated. Make it saturated, and then dip your paper in and let it dry. That's all potassium iodide starch strips is. It's just, they got some aqueous iodide salt, and they dip some paper in it and let it dry. And the salt will be on top of it, you know what I mean? And you use that. But if you don't want to do that, you can just go by the color like I said.